hyperbolas. Be quiet, listen up, take some notes if you need to. Sam, pay attention. So, oops, sorry, I didn't mean to do that. So, okay, that's not going. Put your phones away. A hyperbola is a set of all points x, y in a plane, the difference of whose distance from two distinct fixed points, also called the foci, very similar to the definition of a ellipse, okay? The foci is a positive constant. See figure 9.27, okay? So with the hyperbola, the difference between a hyperbola and an ellipse is that in a hyperbola, you add these two things together, and that comes up with some constant number. And from the sum of those two segments, you generate an ellipse, okay? With a hyperbola, you take the difference, you subtract this, minus this, and when that difference is a constant, that gives you all the points on the branches. Each one of these is called a branch of the hyperbola, okay? So you subtract the difference from a fixed point called the focus, and from two fixed points, if I subtract those two distances, I end up with a point on my hyperbola. So for instance, if I were to go like from here to here and subtract the difference from here to here, that's how I come up with this point right there on the hyperbola. You kind of get, it's kind of weird because it's not as straightforward as a ellipse. Okay, d2 minus d1 is a positive constant. So if I were to go from here, right, from here to here, minus the distance from here to here, that's going to give me a constant, okay? And when I find, if I were to subtract this piece minus this piece, I would end up with this point right here, okay? So that's kind of how we get the curve. That's how you come up with the curve of a hyperbola. Again, the distance from the center to the focus is called c. So if I go c to the focus, either direction, that's finding from the center to the focus to either foci. This is focus 1 and focus 2. That is c. And a is the distance from the center to the vertex. Notice in this case, c is always going to be bigger than a, right? And so that kind of falls on with the hyperbola. The relationship exists between c, a, and b is that c squared equals a squared plus b squared. So for hyperbola, it's just like the Pythagorean theorem. For an ellipse, it's c squared equals a squared minus b squared. Okay, so you got to be aware of that relationship is different for a hyperbola than it is for a ellipse. Okay, the axis that goes through the foci, that's called the transverse axis. Okay, what does B represent? We'll talk about that in a little bit, but B actually represents the direction kind of this way that the parabola or the ellipse stretches. So when we talk about B is what happens is I draw in some asymptotes. We'll see in a little. Oh, that's not a very good asymptote. But with a hyperbola, you have asymptotes, and B represents kind of how the x direction, or if it's going the other way, the y direction of the asymptotes. I'll show you what I mean later on. Okay, but B kind of controls how wide this ellipse is. Okay. Yes? We'll talk about B later on. But right now, we'll just worry about A and C. Okay. So we're good to move on? Here, I'll kind of show you. Well, I found a decent thing on Desmos. Let me go back to here. Okay. Talk about this. Where is that thing? Desmos. I guess. Oops. Back. Can I copy this? Oh, I have to be on edit. Okay. Escape. Watch. So I found this little link that is a hyperbola generator on Desmos. Some of you guys are familiar with Desmos. Hopefully this will go to it. Go ahead. Go. Left it in it. Why is it not going? Here we go. So on Desmos, here's a hyperbola, okay, and it's kind of cool that what you can do. So in this case, A is the distance from here to here, right? See that? From here to here and from here to here, and I could drag A, right? And that changes my hyperbola. Okay? So you notice that as A gets further from the center, it gets more stretchy. Okay? Here's C, the distance from here to here. Notice as I change A, B down here, which is equal to the square root of C squared minus A squared, will get as A gets bigger, B gets small, okay? Which kind of controls the skinniness of my hyperbola. You understand that, guys? So B, it doesn't really show B on here, but B. I think this is the orange. I think this is B right here. So as A gets bigger, yeah, I think the orange between these two dots here and here, I think that's B. But that it controls the spread. Okay, we'll talk about it in a little bit. Okay, and as A gets smaller, notice that B down here gets bigger, right? See, B is going up as A gets smaller, like that. And when C and A are the same, what happens? What do I get when C and A overlap? I get a straight line, right? I try to make them exactly the same. I get a straight line. When A is close to 0, I get kind of a vertical line, right? So that's it's kind of cool to look at that. But so notice that when the focus is closest to the vertices of the hyperbola, what happened? What happened? Where did it go?
It's still in a vertical straight line.
Oh, it is?
No, move the black one.
Oh, move this one. As the focus and the vertex get close to each other, my hyperbola gets skinnier. So it's kind of cool to look at that. All right, so let's, whoops, where'd we go? Back, anyway, let's go back to our, my PowerPoint, wherever. We'll come back to this slide anyway. All right, so general form. The standard form of, what's that black thing up there? Oh, what happened? What's this?
You can take a diagram.
Where did it go? What happened? Okay. There we go. Oh, something happened. But, it's part of that picture that's been put up. So the standard form of the equation of hyperbola with center in HK, it's almost the same as an ellipse. The only difference is that instead of this being a plus sign, it's a minus sign. Okay? And the other thing to notice is that So transverse axis is horizontal. So in this case, if x comes first, my hyperbola is going like this, okay? In this case, if y comes first, then my hyperbola is going like this, okay? And in this case, remember I said yesterday that A is always bigger than B, okay? With a hyperbola, that's not true, okay? So A could be smaller than B, or A could be bigger than B. It doesn't matter, okay? So A can be bigger or smaller, bigger or smaller than B, because that just kind of controls the squishiness or the stretch of your hyperbola. Okay? Notice c squared equals a squared plus b squared. For one centered at the origin, then it takes this formula. Okay? And if it's vertical, it takes this one. Questions about that? HK is a center. You get it? So the only thing so if y comes first, then it's going this way. If x comes first, it's going this way. All right? Doesn't matter about anything. All right, so let's move on to the next slide, where they talk about find the center vertices and foci of the hyperbola. So we're going to do that right now. What would I do first? What would I do first? Divide everything by 36. When I divide everything by 36, okay, this is very similar to that last problem I did yesterday. I get y squared over 9 minus x squared over 4 equals 1, which means that A always comes first in this case. So A is equal to 3, and B is equal to 2. Okay? Find this out. So this hyperbola is going which way? It's going vertically. It's centered at the origin. A is 3, so you got 1, 2, 3. I mean, it doesn't say sketch it, but if you're going to sketch it, the vertices are here. And B is 2. Okay? So what does B being 2 mean? What B being 2 means, okay, is that you could find the foci without actually sketching it, but I want to sketch this in. It means you go over 2 like this and this. And then in here, you get your Moby board. You guys all have Moby boards at home, right? Okay, good. Okay? And then you draw a rectangle or a box that looks like this. Okay? So this distance, if you're wondering what B was, this distance from here to here, that's B. This distance from here to here, that's A. Okay? How the box helps you sketch the hyperbola is by sketching in the asymptotes. Okay? So asymptotes are lines that hyperbolas, they approach an asymptote. So here is one asymptote. Here is the other asymptote, like this. Ooh, I did that really well. And then now I can sketch my hyperbola because I know that these are vertices, okay? And then my hyperbola goes towards those asymptotes. So it's going to go out this way over here, okay? And then it's going to go out this way over here. There's one branch, okay? And the other branch goes this way over here, and this way over here. Not very good, but that's how B helps you. It kind of controls the thickness. So if B were smaller, okay, if B were smaller, then it would be more squishy, right? You get that?
So B is the box or the lines?
B is the width of that box.
Okay.
Right? And A is kind of it's half the width of the box. 2B would be the entire width. And A is the distance. It's the other dimension of the box, or half of the dimension of the box, but it's the distance from the center to the vertex.
So
yes?
it's basically basically like still the vertice of like the x-axis then? Like that's kind of
Yeah, I mean, there's no vertex there because the hyperbola is actually over here, right?
but it's like the same distance.
Right, yeah. And so then to find the foci, related by c squared equals a squared plus b squared. Well, I know a squared is 9, and I know b squared is 4, right? So c squared equals 13. So c is equal to the square root of 13, which is like 3 point something, which would make sense because this is 3, right? So the focus would be inside of those vertices. So this focus would be at 0, comma, positive square root of 13, and this focus would be at 0, comma, negative square root of 13. Yeah? Yes, sir.
How do you know which is going to be A and B since A can be smaller
A,
or bigger?
A always comes first. So with a hyperbola, A is the thing underneath the first thing. Okay? Okay? Because A is the distance from this center to the vertex. So if y squared is coming first, A is the square root of this, which is 3, because it's on that axis. You get it? Okay? So A always, with a hyperbola, A always comes first. Okay? With an ellipse, A is the bigger number. Just the way, in different books it's defined different ways, but in this case,
And the leading coefficient has to be positive.
the leading coefficient,
Has to be positive.
yeah, because if it's not, then you have to switch places. We're going to do one like that in a second.
Okay. Sure. So that's it.
Okay, yeah. So find the standard form. So here we're going in reverse. Okay. So again, I like to sketch things before I do them because it helps me think about it. Find the standard form equation. My hyperbola is centered at the origin, so it should be pretty easy. With transverse axis of length 4 and foci at plus or minus 3, 0. Okay. So that's 3, 0. That's negative 3, 0. The transverse axis has a length of 4, which means that the vertices have to be where? If the at plus and minus 2. Okay? So the vertices are here at plus and minus 2, 0, right? That's 2, 0. And then the hyperbola is going to look something like that. Whoops, not very good. But, and like this, plus or minus 2, 0. And then you will have to find b in order to find the equation. Well, you know this is x squared comes first. What's a? What's a? 2 is the distance from here to here. So a squared is 4 minus y squared. You don't know what b squared is, but we're going to find that equals 1. How do I find b squared? Huh? As c squared equals a squared, c squared equals a squared plus b squared. I know that foci are at plus or minus 3, 0, so what's c? C is 3, so c squared is 9. A, we know, is 2, and a squared is 4, plus b squared. So b squared equals 5, so that's what goes in there. Okay? So you just write that as x squared over 4 minus y squared over 5 equals 1. All right? Got it? Not that horrible? Is that horrible? Okay. Okay. Yes, sir.
How do you know that it's a horizontal transverse axis?
Because they tell you that the foci are plus or minus 3. So the foci were plus or minus, or 0 plus or minus 3, then it would be going that way, right? Okay. Can I go on? I'm going on. I gotta change colors. Going on. Okay? So this is kind of what I was showing you. Kind of what I was showing you is that if here's how you find the equation of the asymptotes. I tend not to do it this way, but basically, if it's a horizontal one, like this one right here, then you can find the asymptotes by going y equals k, which is like the y-intercept, right? Or the, yeah, it's the, actually it's the, yeah, it's the y-coordinate of the center of your ellipse. This is, they're converting from point-slope form, so point-slope form looks like this. Y minus y1 equals m times x minus x1. Remember this, point-slope form? Maybe you learned that. And if they bring the y1 over here, y equals y1 plus m times x minus 1. Well, in this case, this point x1 comma y1, that's the center of your, or in this case, h comma k, that's the center of your hyperbola. You understand that? So that's where this formula comes from. hk is the center of your hyperbola. B over A is the slope of your asymptotes. So if it's going horizontally, then this is A and this is, excuse me, if it's going horizontally, that's right, then this is A and this is B, right? So the slope is going to be B over A. If it's going vertically, like one, if I were to draw it in over here, right? If I were to draw one in like this, then this is A and this is B, so the slope is going to be A over B. You understand that? Some of you? Yeah? Okay? And it's plus or minus, because one of them is minus and one of them is plus, right? And so that's how you find the equation of your asymptotes. We're going to do one where we find the equation of the asymptotes in a second. Okay? So can I move on? Move on? Yes? Are you excited about this? Do you need to stand up and sit down a few times? No. Okay, then let's move on. All right. All right. Uh-oh. Sketchy hyperbola given by the blah, 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 blah. So this is like the one on the board over there that Nikki did a nice job with, right? So we just completing the square. Not too bad. This is not too horrible. 4x squared plus 8x minus 3y squared. Is that it? Equals negative 16. Everyone understands what I just did there? What do I need to do next? Factor out a 4 from those, whoops, 8x, not 8y, right? Okay? Factor out a 4 from those first two terms. 4x squared plus 2x minus 3y squared equals negative 16. I'm going to complete the square. 4 times what? X plus 1. This is where it gets kind of weird. Watch, this is kind of a fun one. Minus 3y squared equals negative 16. What do I have to add to this side? Plus 4. Oh, you guys are good at this. So now I have 4 times x plus 1 squared minus 3y squared equals negative 15. Pay attention here, Colton. I mean negative 12. I knew that. I was just thinking of one. I don't know. Okay? Then what do I have to do to the right side? Divide everything by negative 12. And so this kind of answers your question, Colton, what you were asking about before. If I divide everything by negative 12, okay, then what happens is this one becomes a positive one, and this one becomes a negative. See that? Okay? And then so I'm going to change this over to y squared over 4. You understand that? Because a negative divided by negative is a positive. This one becomes a negative one minus 4 goes into 12 3 times x plus 1 squared over what? 3 equals 1. Got it? And so then if I were going to sketch this, which I am, okay, The center is where? At -1, 0. Okay, so here's the center of my hyperbola. A is equal to 2. B is equal to the square root of 3. Okay? So from this -1, 0, one vertex is going to go here at 1, 0. Another vertex is going to go here at -3, 0. You guys understand that? Hello? What? Because this is the point, this point here is -1, 0, right? And A is the distance from here to here. So A is going to be -3. And I mean, if I add -2 in this direction, that becomes negative. So that's one vertex, because A is the distance from the center to a vertex.
But isn't it a vertical? Isn't it a vertical?
Oh, crapola. Okay? You guys are right. Okay? So that's still 1, 0, but it's going up, down, isn't it? Okay? Just checking it. Make sure you guys are paying attention. It's going up, down. Okay? I just messed that up. Let's get rid of these. Okay? Thank you for catching that. So it is going up, down. Okay? So, and it goes over this distance from here to here is, how far is that distance? That's square root of 3. Okay? And so, so let me just draw a box in here. There's a box that I'm going to sketch in. And then I could draw in some asymptotes in a different color. Because it might not come out very, basically. Asymptote, asymptotes, and then the hyperbola goes this way here. Ooh, that's really bad. I have to sit and try to draw it, okay? And it goes this way over here. And then it goes this way over here. Not that bad. It's very colorful, though. And it goes this way over here. Okay? So I'm not quite done with the problem because it said sketch it and find the equation of the asymptote. So since this is going vertically, this distance, so this is y equals k. What's k? What's k in this case? K is 0 because k is the y coordinate of the center. So y equals, let's just write it like this, plus or minus a over b x minus h, which in this case is -1, right? Okay? A, we determined, is 2, and b is the square root of 3. So the equation of this asymptote is y equals, I could get rid of the 0, plus or minus a, which is 2, over the square root of 3, x plus 1. And that's the equation of that asymptote. If you want to rationalize the denominator, you can, but that would be fine. Okay? Yes? No? We're okay with that? That's kind of tricky, but it's a lot of steps. All right. Last thing. Eccentricity for an ellipse, C over A. I already talked about that. So with this case, it has to be must be bigger than 1, bigger than 1, okay? And then this is for this. Oh, that should say hyperbola. That's a typo. Hyperbola, okay? C over A must be bigger than 1 because remember, if we're talking about a hyperbola, if C is not bigger than A, right, then the focus would be outside of the hyperbola, which it can't be. Okay, so it must be bigger than 1 and close to 1. Like if you had a C over A of close to 1, is very narrow. okay? Narrow, narrow, okay? And big, it's fat, okay? So that's kind of, and you could look at this to show you this demo that I plugged in, okay? So that's all you really need to know about the eccentricity. And then they have this horrible problem that I always get. It's kind of weird, okay? But, so it says 2 microphones 1 mile apart record an explosion, microphone A. So it's just trying to show you that there are some applications of this stuff. And sometimes they talk about it with the lightning strikes and the speed of light. Here they use the speed of sound, okay? 2 microphones 1 mile apart record an explosion, microphone A receives the sound 2 seconds before microphone B. Where did the explosion occur? Okay? And so what happens here is that sound travel, they will tell you in the problem, sound travels at 1,100 feet per second. Feet per second. How far is a mile? 1 mile equals 50 to 80 feet. So if these are the microphones, okay, how far apart are those microphones? 50 to 80 feet. That means that the distance from here to here, which is C, is how much? 50 to 80 divided by 2, which is equal to 6. What is it? 2640, right? 2640, and then since it takes the difference that it takes to travel from here to here minus here to here is how long? How long does it take for them to between? It takes 2 seconds, okay? 2 seconds, okay? So that means that the difference between this minus this, okay, is equal to 2,200 feet, okay? And it also turns out that A, this is where A is equal to that difference divided by 2. So it's equal to 2,200 divided by 2, which is equal to 1,100. So this is the tricky part, which you have to look at some geometry to figure it out. But A is going to be the difference between this, and the way you do that is by this minus this, you get A, okay? And so A, just believe me, this is 1,100, that's 1,100 feet. And then you can plug in that C squared is equal to A squared plus B squared, and you could find the equation of this hyperbola, and then all they want you to say is that the hyperbola occurred, or the explosion occurred somewhere on this hyperbola with the equation x squared over 1,100 squared minus y squared over, you would have to do the math to go a squared plus b squared equals c squared. We know c squared, so we'd have to go 2640 squared minus 1,100 squared, and that's b squared. That would give you b squared, and then you plug that into this down here, and then you would have the equation of this hyperbola, and then it will say, where did it occur? And all you say, it occurred somewhere on the hyperbola with this as its equation. That's all they want you to say. It's kind because it could occur anywhere on this hyperbola, because the difference between this distance from here to here and this distance from here to here, you're going to still get that 2,200 feet is the difference. And A is this. A is going to be this minus this. I'll try to think about the geometry of that in a little bit more and talk about it tomorrow. Okay. Last thing. This is this the last thing? Please be the last thing. Okay. Is this the last thing? Oh, not quite. So this is real quick. In the very beginning of this chapter, I talked about this being the general form of any conic section. Okay. We really don't have to worry about this one, this thing, because this is for if the hyperbola, ellipse, or circle, or parabola is rotated to something other than horizontal or vertically. But if A equals C, meaning the number in front of the x squared and the number in front of the y squared is the same, then I have a circle, right? So if I have something like 4x squared plus 4y squared equals 36, that makes the equation of a circle. Right? If either A or C is equal to 0, then I either don't have an x squared or I don't have a y squared, which means it's a what? If it's got to be a parabola. Okay? So if either A is 0 or C is 0, then I have a parabola because you won't have an x squared term or you won't have a y squared. If A times C is bigger than 0, meaning both numbers are positive, then you have an ellipse. And if A times C is a negative number, meaning either the number in front of the x squared and the number from the y squared is negative, then you have a hyperbola. So just looking, what is this? So you don't have to, what this is saying, you don't always have to complete the square. What shape is this? What shape is this? Parabola, ellipse, circle, or hyperbola?
Parabola.
Couldn't be a parabola, a hyperbola, because it's got to have a y squared in it. Okay? So since both things aren't squared, you only have an x squared, this has to be a parabola. Okay? Okay? This has a positive x squared and negative y squared. What do I have? What do I have? Positive x squared, negative y squared. That's got to be a hyperbola, okay? Right? Because A times C is less than 0. This is A. This is A. This is C. 1 is C. Okay? What's this? This is an ellipse. And this is a circle. Okay? You get that? It's just, you don't have to do all the conversion and put it into the standard form. You're just looking at the equation to figure out what thing you have. Okay? And the very last thing, I promise this is the very last thing. Okay? We have an hour left, but I want to talk about the, yeah, I know, but I also want to talk about the conics project. You got your photo there, Colton? Good. And then the very last thing is that hyperbolas, we don't really talk too much about these kind of hyperbolas, but they do exist because we're talking about hyperbolas that have two branches that are reflections of each other. But this type of hyperbola, if you have one like, this is like a hyperbola like y equals 5 over x. We already talked, I think, earlier about that type of hyperbola, which looks like this, right? So if you have something like xy equals a constant, like x times y equals, so another way to write this is x times y equals 5, you get this kind of hyperbola, yeah? Which we're not going to talk about the foci and the vertices and all that kind of stuff in that kind of hyperbola. Okay? So you can start on that. I think, is that the homework, the same that's on Schoology? You can start on that. I will I'm gonna check out the last 3 homeworks that you have for me, and then I'm gonna talk a little bit about the comics project after that, okay? So, I'm gonna stop.